In this lecture for S2 Business Mathematics for CN Corporation, we are looking into the properties of determinant. So, if every element of a row or column of a square matrix is 0, then determinant of A will be 0. It means that, suppose if I am having a matrix A, and the elements are 0, 0, 0, 0, 0, 0. So every row and column of this particular matrix is 0. Then the determinant of this particular matrix is 0. It can applicable for a matrix which have one single row full of zeros. So this is applicable to any row containing 0. The determinant of that particular matrix is also 0. Now let's consider the second property, that is determinant remains unaltered if the rows are changed to column. So let's see an example. A is equal to 1, 2 and 3, 4. Okay, now let's find what is the determinant of this value. It is 4 minus 6, so you'll get the answer 2. Now if I am interchanging the particular row, this is our row. So if I am interchanging the row to column 1, 2, 3, 4, the value will be A2. Let it be A2. So the value will be 4 minus 6. So it says that determinant of A is equal to A transpose determinant. That is second property. So second property states that a determinant remains unaltered if the rows are changed to column or vice versa. So determinant of A will be equal to determinant A transpose determinant. Determinant of A will be equal to A transpose of a determinant. Now let's see what is the property 3 state. So we finished the property 1 and 2. Now let's see the property number 3. If two rows or a column of a determinant are interchanged, the sign of the determinant will be changed. So if you change the rows or a column, the determinants are interchanged. So the change will happen in the sign of the determinant. So let's see this same example. So let's say this same example. So we got this determinant as minus 2. Let's see if I interchange the row. This is the row 1 and this is row 2. So let's interchange the row. So let the row 2 be the row 1 and row 1 will be the row 2. So this is the interchanged one. So let's see what is the determinant over here. So it is 6 minus 4 and you'll get the answer 2. That is what it says. If you interchanged the row or a column, only the sign has a determinant of this particular, the sign of the determinant will be changed. Whenever you interchange the particular row or a column, the sign of the determinant will be changed. Now let's see what is the fourth property. So the fourth property states if two rows or a column of a determinant are identical, the value of the determinant will be 0. Now, see an example A, 1, 2, 3, 1, 2, 1 and 1, 2, 1. So, these two, row 2 and row 3 are identical. So, in that case, the determinant will be equal to 0. That is rule number 4. Now, we have property number 5 which states that if all the elements of one row or a column of a determinant is multiplied by a constant k, and the value of the new determinant will be k times the value of the original determinant. So let's see, let's take an example of this matrix. Let's take the example of this matrix. So we have a matrix and we need to have a scalar value. So let the constant k. So this is our matrix and we have a constant k. Let it be 2. Okay. Now let's take the determinant of A, that will be 4 minus 6, we get minus 2. Okay, if I'm adding the constant a k, so I'm multiplying the scalar value 2 to each of the elements of this matrix. So I'll get 2, 4, 6 and 8. So this will be my new matrix. Now if I'm finding the determinant of this particular matrix, it will be 16 minus 24. That will be minus 8. So according to the property, it states that if all the elements of one row of a determinant is multiplied by a constant k, value of the new determinant will be k times the value of original dependent. So k times means 2 times of the original determinants. Let's see. Ka is equal to, determinant of Ka should be equal to k raised to n determinant of A, where n means the order of the matrix. Order of the matrix. For our case, the order of our matrix is 2 by 2, so n is equal to 2. Let's see how it goes. So k determinant is, we got it as minus 8, so we are substituting the value, and the k is 2 now, n is equal to 2 as well, and the determinant of A is minus 2. So let's see whether LHS is equal to RHS. So we get 2 square means it is 4. 4 into minus 2 is minus 8. So minus 8 is equal to minus 8 is equal to minus 8. So LHS is equal to RHS. So if we are multiplying with a constant K to a matrix A, the value will be Ka determinant will be equal to k raised to n, where n is the order of the matrix, multiplied by the original matrix. So it will be always k times the value of the original matrix. Okay, that is how we find the determinant of with respect to a constant k. Now, sixth property states that if to each element of a row or a column, the corresponding elements of another row or column multiplied by a constant is added, then the value of the determinant remains unaltered. So, if you are adding an element of a row or column to another row or column, multiply with a constant, the value of the determinant will be always the same. Now, let's see an example how we will tackle such type of questions. So, let's see some examples. Okay, so consider this question. You're asked to show that determinant 1 A B plus C, 1 B C plus A, 1 C A plus B equal to 0. So you need to prove that the determinant of this particular matrix will be equal to 0. So you need to go through the properties of the matrix, what all cases it can be. So if every element of a row or a column of a square matrix is 0, then that particular determinant will be 0. There is another chance, the possibility of having a property 0 is the fourth one, that says that if two rows or columns are identical, value of the determinant will be 0. So let's, how can we make it identical? So if you add this particular column, that is column 2 and column 3, we'll be able to get A plus B plus C. So everything will be common, right? So let's see, we write it as column 3 is equal to column 2 plus column 3. So this is the operation that I am going to do. So I'll keep other columns as such, 1, 1, 1. The second column is A, B, C. So the transition is occurring only on the column 3. So it will be A plus B plus C. It is A plus B plus C. And next is A plus B plus C. Okay, so A plus B plus C is common to all the columns right now. So what I'm going to do is I'll take the A plus B plus C outside. So I'm taking it outside so that the determinant will be 1, 1, 1. A, B, C, again 1, 1, 1. So we can see that column 1 and column 3 are identical. So according to the property of rule 4, either row or column should be equal. So in our case, the two columns are equal. So determinant of this particular matrix will be equal to 0. So the value will be A plus B plus C times 0. We'll get it as 0. This is how we prove using the property rule. Now let's see another question. How do we evaluate such question? So let's evaluate 1, 1, 1, 1, 1 plus x, 1, 1, 1, 1 plus y. In the previous case, it was asked to prove that the determinant of this one is always equal to 0. Here you need to find what is the value of this determinant. So what we can do is, you can subtract the particular row. So this is R2 and this is R3. So the operation you can do is, you can subtract R2 with respect to R, because 1 is common in all the cases. So you will say that R2 is equal to R2 minus R1. Same you can do for R3 as well. So R3 is equal to R3 minus R1. So you're using R1, and with the R1 you're subtracting R2 and R3. So let's see what is the value. So it will be 1, 1, 1. Okay, the row 1 will remain the same. So R2 is 1 minus 1, 0. 1 plus x minus 1 will be x, and the other one is 0. Likewise, 1 minus 1, 0. 1 minus 1, 0. 1 plus y minus 1 is equal to y. Now let's see what will be the answer. So 1 into, so we have simplified the same equation. So it will be 1 into xy minus 0. Rest of every elements will be 0. So we don't have to consider anything else, only the first one. So this is the simplified method to find the determinant. If we are going to the other way around, we have to do a plenty of operations. So in order to avoid such operations, we have reduced this particular value determinant by applying the property rule. So by applying the property rule, we simplify the particular determinant, and we found the answer as x and y. Okay, now let's consider another example. If it is a value, so evaluate minus 1, 2, minus 3, 2, minus 3, minus 1, minus 3, minus 1, and 2. So how do we evaluate this one? So what we can do is, to the column 1, when you add each elements, that is minus 1, plus 2, minus 3, what will you get? So it will be 1 minus 3, you will get it at minus 2. The other expression 2 minus 3 minus 1 will be 2 minus 4, that is minus 2. Now, minus 3 minus 1 plus 2, what will be the answer? Minus 2. So, we are making the first column elements similar. Okay. So, what will be the operation? So, C1 is equal to, we are adding C1 plus C2 plus C3. So C1 is equal to, we are adding C1, C2 and C3. So we'll get the answer as minus 2, minus 2, minus 2. Then we write 2, minus 3, minus 1, minus 3, minus 1, 2. Okay, when this occurs, what we can do is, we can take the minus 2 outside and make it 1. So it will be 1, 1, 1, 2, minus 3, minus 1, minus 3, minus 1 and 2. Okay, now what can we do to the next? In order to get the simplify, we can subtract the first row from second and the third row. So subtracting R2 minus R1 as well as R3 is equal to R3 minus R1. So let's see how it goes. So minus 2 into, don't forget to write the minus 2. So write the 1, 2, minus 3 as such. Then R2 minus 1 means will be 0. Minus 3 of minus 2 will be minus 5. Minus 1 of minus 3 will be 2. Will be 2. Then the other one is 0. Minus 3. Then we have 5. Okay. Now let's find the determinant of this. So it will be minus 2 into. Then 1 into minus 25 minus of minus 6. The others will be 0. Okay. Now let's see, minus 2 into, we have minus 25 plus 6. So minus 25 plus 6, it is minus 19. So the answer will be 38. Okay. So what we have done is, in order to simplify this, we add all the elements in a column and we got the common element as minus 2. We take out the minus 2 outside and made it as 1. If it is 1 means you can reduce this particular matrix so that we don't have to evaluate the other value. So we subtracted the row 2 minus row 1 and R3 minus R1. So we got the new value, and when you do the normal determinant, we got the answer as 38. Hope the properties of matrix is clear for you. Thank you.